Welcome to Study Loop.
For no deflection, the magnetic and electric forces must be equal in magnitude and opposite in direction. That means the net force should be zero if we want no deflection. This means the direction should be opposite and the magnitude should be same. Now Fm is equal to Q times, so the cross product of V cross B. So this is equal to QVB times sine phi, as the point B points in the z direction and velocity points in y direction. So they are perpendicular and sine theta becomes 1. So this is basically the magnitude is Q times V times B. Now the direction will be given by J cap cross, as you can see there's a negative sign here. So negative of K cap. And this is equal to, so this is basically given by the cross product by the right hand rule. So this is negative of I cap or negative x-axis. Similarly, the direction of E is equal to the magnitude and direction of the electric force is Q times the electric field. So the magnitude will then be just equal to Q times the magnitude of electric field, and direction of this should be along the electric field, like not exactly along, depending on the charge is positive or negative. If charge is positive, this is along electric field. If charge is negative, this should be opposite to electric field. And for our case, we want the direction of this force should to be along positive I, that is opposite to the direction of Fm. Now let's go ahead and find the magnitude of the electric field. So we plug these two values in this equation, and we have already taken the negative sign into account. So basically we want the magnitudes of these two to be equal now. So QE is equal to Q times V times B, and this gives the electric field to be V times B, and we calculate that using the values we are given. So notice that we have already taken this negative sign into account over here. So now you just need the absolute value of the magnetic field over here. So we do that and we find the magnitude of electric field to be 7898 Newton per Coulomb. Now for part A, the charge is positive. This means that for the electric force to be along plus I cap, E should be positive as well, and it should be along plus I cap. So E vector should be along plus I cap. Now for part B, Q is negative. So for the force to be along plus I, the positive x-axis, the electric field should be opposite to the x-axis. So this is negative I cap. Now, yeah, I think that's it. The same configuration of electric and magnetic field works as a velocity selector for both positively and negatively charged particles. So, yeah, keep that in